black and white does in the jitter verse is it throws out the red, the green, the blue, and the alpha and gives me a single plane of information. So this is black. This is RGB into black and white. One plane image, right? So it just throws everything out. That's not how you spell it. One plane image. So this is me, black and white. Easy object to do some statistics on something is this thing called JIT3M. This is a object that just reports some really simple statistics about a picture. And a lot of times, simple statistics is really all you need. So this reports the min, the mean, and the max of the image. So what this is telling me, right, is that the darkest pixel in this image is a 5. This is in the 0 to 255 scale. So it's saying the darkest pixel in this image is a 5, which is almost but not quite black. The brightest pixel in this image is 253, which is almost but not quite white. And the average pixel in this image is 93.5-ish. Does that make sense? So this is sort of telling you. So this is reporting the mean. You guys don't know what I mean when I say the mean? Right? You add them all up, divide them by how many there are. Right? So it's not the median, not the mode, it's the mean. If I walk out of the way, right, it goes up. It goes up to 112. Why? Yeah, it got wider because I'm wearing a black t-shirt, right? So I walk in, it'll drop. Right? So I could do something really simple with this, right? I could say, hey, are you under 100? Right? And then get me a toggle box, right? And so that's true. Now it's false, right? So now I can find me in the frame, right? That's me. There I am. There I'm not. There I am. Right? And then we could do something like, this is testing this every frame. I can put in a change to get rid of the repeats. Right? So this will filter out repeats. Filter out repeats. So if I print this, right? If I print this before the change, it's saying 1 1 1 1 1 1 1 1 1 1 1 0 0 0 0 0 0 0 1 1 1 1 1. If I do it after the change, right? It'll only do it when that state transitions. So I walk out of the way, it'll say 0. I walk into the way, it'll say 1. Right? And then I can say, I'm going to look for it to be true. So I'm going to do a select one, put in a big button so we can see it. And then we do this, 60, 63, 66, 69, make note. We're going to make some MIDI. Note out.
Which object do you use for grab an external camera?
It's the same one. Use JIT-QT grab. I'll show you. An external camera shows up as a different input, but I'll show you. So if I walk out of the way, right, and I walk into the frame, it should work. There we go. You're sort of like generic villain. Right, so this is our like low rent security system. Right? You could call the super secret. You can detect walking into a frame that way. Right? Right. I think the way you're supposed to do it, actually, we're doing this kind of wrong, is let's move this all up a little bit. Is we would say, plus, and we would say, let's say, trigger int bang, and let's say counter 0 to 3, multiply by 3, and that'll add to all these numbers. Let's see if this works. Let's look at this. Okay. 0, 1, 2, 3. Yeah, let's try this. So if I walk in the frame, oops. Did I turn off? Yeah. So let's try this. Let's see. That's not quite right. Oh, you know what? I'm got this in the wrong place. Sugar bang. You go there. You also go there. Shucks. There we go. And then do it again. There we go. Yeah. Alright. Yeah. Alright, so that's good. That's what you're supposed to do. Alright, so this is our sort of like villain detector. Villain detector. If you have an outside camera, so if you plugged in a DV cam or whatever, JitGrab will see it. When you say open, what there is there's an input attribute where you can change the input. And it always depends on the computer which one counts as which input. So you can always look at the help patch and see. So if I go to the help thing and say get input list. Oh, I gotta open the digitizer first. Let me close this. So if I say open, get input list. These are all the inputs. It only sees one input, right? But if I had another computer hooked up, there would be another thing in this list. And they're just numbered inputs. So if you have like, 3 cameras hooked up, they should be input 1, 2, and 3. Or maybe input 0, 1, and 2. I'm not really sure. Maybe it starts at 0. I'm not really sure.
Camera just needs to be on.
Needs to be plugged in and on before you start Max, usually. It's not going to do a good job of, like, if you turn it on while Max is running, it might not find it. But yeah, that's all you got to do.
And you have to.
Yeah, you can have as many as you want. There are some restrictions. So like DV cameras, the driver is set up for only one source at a time. So if you have multiple Sony DV cameras, you can't use them both simultaneously, right? It'll get confused. But USB cameras, you can have multiple ones at the same time. IIDC cameras, you can have multiple ones at the same time. Digitizers, it depends on the digitizer. So like the Black Magic box cannot read on the analog ends at the same time as the HDMI input. You have to choose, right? So you can't use one Black Magic box to get 2 inputs. It won't let you do that. But it depends on the input. One way to get a ton of cameras in is to use is to use a video multiplexer with a digitizer. So if we go to Super Circuits, video quad, this thing, come on guys, Everplex. Yeah, so like this is or like this is ridiculous. This is overkill. But this is like an 8-channel security DVR. But this is like the kind of simpler one, right? And it's like $100. And basically, it's a box. Look, it's a box. And they have a black and white one too. And in the back are 4 inputs, right? And an output, right? And what they do is they take the 4 cameras in and they go boom, 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 and deliver them as one image. Does that make sense? So it just like multiplexes them. And then you send that to a digitizer. And that gets you 4 cameras in one image. And then just inside the computer, then you split it up again and treat them individually, right? The thing with resolution in computer vision is for most of what you need to do, depending on what you need to do, you don't actually need a high definition video input. So like all that dance shit that Chunky Move does, they basically do with like a standard industrial camera. They use one of these and it's like 640 by 480. Because all they need to know is where like a large thing is on a screen, like a human. They're not like tracking fingers, right? They're just tracking like the core of the dancers' bodies. So they don't need a particularly fancy kind of system for that. So that's this, right? So this is just a kind of basic, this is just kind of a basic kind of presence detection algorithm. That's all this is, right? So it's looking to see if something is there or not. So you can call this presence detection. A corollary to that would be something like motion detection. right? So let's make one of those. Save as. Let's call this motion detection, right? So this would be something like this, right? I could say, okay, Mr. JQT grab, I want to only look at the unique frames coming out of you. So it's a JIT change. This will filter out the repeats in the frame. Okay. Filter out repeat images, right? So this way it doesn't matter. So now my metronome can still be high. Like if I look at my FPS GUI. If I look at my frames per second here, I'm getting 200 frames a second. There's no way my camera is putting out 200 frames a second. But if I look out here, it'll drop to like 20 or 15. I think the built-in camera on your Mac is 15 frames a second, right? So it's getting rid of all the repeats. Does that make sense? And so then I could do a little bit of math. I can make it black and white, same deal, right? And then I can say this. So what I'm going to do is I am going to send it into a trigger, and LL stands for list, because that's technically what's coming out of here. This JIT matrix, blah, 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 is technically a list. It's two values in a list. And I'm going to run that into an object called JIT ABS diff. Okay? And so this is the absolute value of the difference. Okay? And what I'm going to do is I'm going to wire it like this. I'm going to cross these inputs and put it out. And now it's just going to show me what's moving. You guys see that little silhouette there? That's the difference, right? This is the absolute value of the difference. I'm crossing them because of the way the max messages work. What I want to do is I want to send the image into the left to trigger a computation, then send an image into the right to save to the next frame. Right? Max is a little bit like Ghostbusters. You usually don't cross the streams, but here you want to cross the streams, right? You want to actually have a thing compute and then you store the same thing for later, right? So this will look in motion, right? And then I can post-process it. I can say, hey, are you greater than 20? Maybe. Let's find out. And this will make it a binary image, right? So now any motion that's above 20, this is something you do a lot in computer vision, you make binary images. Anything that's above 20 will go to white, anything that isn't will go to black, will go away. Right, so this is like a threshold. You guys see that? And now, look at my 3M numbers. Now it's about when I stay still, it'll drop. And when I move, it goes up. Right? So now I could set my villain detector to be a greater than 10. Right? Right? So now it's like Mission Impossible if I move like really fucking slowly. I'll try to get out of their way. Right? I can get out of the way. Right? You get it? So that's like a threshold for motion. Right? Does that make sense?
Yeah.
So that's like a simple thing. And what you can imagine doing, a lot of stuff that you can do that's pretty cool with interactivity is just about doing shit like this and doing things like subdividing the frame, right? So you can imagine we could take this stuff, right, and let's take this bit, maybe not all of it, but let's paste it into something, right? And I don't really care about the minimum and the maximum. I just care about the mean. I'm gonna like plug that in. Make this. I'm gonna make this threshold thing. All right. Actually, I'll leave that alone. But what I am gonna do though is put a #1 here, a number 1 here, which is something I used last time for that like smoothing thing, and give this an outlet. And so what I'm gonna do here is, this is the first argument, is I'm going to save this. How did that happen? I'm going to save it, and I'm going to call it Am I There? All right? I'm going to save it, call it Am I There? That's not how you spell that. Am I There? Better. Okay, so I got it, right? And I'm going to get rid of this and make sure it works. So I'm going to say, am I there 60? And plug this in. And this should work. It should play a middle C. Yep. Right? Right, so it's working. Right? The 60 got plunked in wherever that was, that number 1. Right? So I got substituted. And so then I could do, whoops, I didn't want to save that over. Hold on a sec. We're going to rewind. Yeah. Right. Save that. Delete all this. Say, am I there? Am I there 60? And we're going to save this again. 3 motion detection 2. Okay. And so what we're going to do is we're going to take this image and we're going to cut it up. So we're going to use an object called JIT scissors. And we're going to say, give me 4 columns and 3 rows. All right? Yeah, why not? So I'm going to plug this in here. And what this will do is this will actually cut up the picture. 3, 4, and I think it's column major, so this should work. So it's 4, whoops. Oh, I didn't know you could do that. 4 columns, 3 rows. 1, 2, 3, 4. 1. I think this is working. 2, 3, 4. Okay. So you see what it's done? It's cut up the picture into a whole bunch of little pictures. And these matrices, right, are there goes Mike again. These matrices are actually a subdivision, right? So this is 80 by 80, right? This is 320 by 240, this is 80 by 80. So this thing's actually looking at a smaller amount of data. So the JIT 3M computation will go faster, actually. And so now what I'm going to do, because I'm too lazy to patch all this stuff, is I'm going to cut this, grab all these, and under Edit, say Paste, Replace. And I'll stick them all in there. So I don't have to connect all those things. But I do have to connect all these things, which is the drag. Well, in about an hour, we're all going to chip in and buy him an auto-tune plugin. All right. Pass around a hat and buy him a $200 pitch correction thing. All right. So I think this will work. So what I'm going to do is I'm going to fill in new numbers for this. I'm going to say 60, 62, 63, Jesus, 65, 67, 68, 70, 72, 74, 75, my God, 77, 79. There we go. So, let's see what's going on here. So what I'm doing is different regions of the screen are causing different notes, right? So up here, there's different notes. That makes sense? So sort of subdivided the image, right? Right? Maybe we should get some visual feedback. I'm going to put a little button under here so we can just see it light up.
What kind of scale is it?
Oh God, what musical scale?
Yeah.
I think it's a C minor scale in MIDI, or an E flat major, depending on what you feel like thinking of as the bottom. Yeah, but that's a C minor scale. 60 is a C, that's a D, that's an E flat, right? That's an F, that's a G, that's an A flat, that's a B flat, that's a C again. Yeah, so it's that's a C minor scale. Let's just light this up so you guys can see. So we feel like we know it's working. Oops. Come on. Right. And now, and then we're going to try to do it with something else. So, yeah. So you can see what's going on, right? Right. It's like a heart. Right? make sense?
Yeah.
So different areas that cause you different modes, right? It would be easy enough to do something like that.
So it can create a glitch, basically.
You can create a what?
Glitch.
A what?
Glitch in it with the areas. I mean, you divide the screen into the columns, rows.
A grid.
Yeah.
Yeah, it's a grid. Yeah, exactly. It's a grid. Yeah, but you could do something more funky than a grid if you want. Yeah, so you could do different regions, right? You can cut out that object-JIT submatrix will let you cut out different regions, right?
Can we do the opposite instead of image triggering sound? Can some predetermined sound can trigger?
Oh yeah, sure. I mean that's kind of like me shouting into the microphone, right? But yeah, you can absolutely do that. Yeah. But this is so like let's make this play a sound file though for a second. So let's say I've got here. Oh good grief. Where is my sounds? Sounds, right? So let's say I was trying to do this is a cello, right? I think. And let's grab these. These are drums. Whoops. What the hell did I just open this in? iTunes. That's exciting. All right. Copy, paste. So let's make like a little. Let's do like a little drum thing real quick. So let's just figure out how to do this. So the easiest. So there's a couple ways to play audio files in Macs. You can play them from disk, right? You can stream them from disk, just the same way QT Movie would stream a video from disk. Or you can load them into RAM, and that gives you a little bit more flexibility. The way you load them into RAM is using an object called buffer, and you give it a name. So we're going to give it the name Fred. We're going to save this. Drum machine, right? So the way you load a sound into the buffer is you say replace, right? That's the equivalent of read. So I'm going to go find my drums, okay? Buffer by itself doesn't do anything. It's just a holding tank for the audio data. So the buffer tilde object doesn't play. It just holds the audio data in a memory. And then there are these other objects that by nature of the fact that this is called Fred can access that data, right? So if I double click it, you can see it loaded something, right? So there's like some sounds in there. What this sounds like is this. Oh, I muted my computer. Wait, there's something that's still going. All right. Bass drum, snare drum, hi-hat, hi-hat. And they're designed, this audio file is edited deliberately so that these things are exactly 1 second apart, which makes the math really easy, right? So I've got a kick drum there, I've got a snare drum exactly 1 second in, a hi-hat exactly 2 seconds in, and another one exactly 3 seconds in. So that just makes like the math of figuring out how to get these independently easy for me. So yay. So I've loaded it in. So if I want to play it, if I want to play it, I need an object called play tilde, and I give it the name Fred, right? And so this thing will access the data in this thing because they're both called Fred. It's a little bit like OpenGL or Jupyter, right? This thing is literally a tape deck. So the numbers you send it in are the play position, okay? Like the play head of a tape deck. Where do you want it to play from, all right? So if you send it the number 1,000, it'll give you the value 1 second in, 1,000 milliseconds in. And just like a tape deck, in order to hear anything, it has to be moving. That number has to be moving, right? If you just feed it the number 1,000, it's just going to play you the sample 1 second in and you won't hear anything. It'll be like holding down a pause button on a tape deck, right? Sound needs kinetic values.
So you need a Q metro?
You need something that's changing. You need a number that's moving. So we're going to do it with a signal, actually. We're going to have a moving signal. So if I wanted to play, so I'm going to hook it up. This is the speakers, right? This is the digital to analog converter. Analog converter, aka the speaker. Speakers. Audio and max, you got to turn on the audio system by setting a 1 to the DAC. This is a volume control. This is a multiply tilde, right? So this is going to basically give me a volume control for the whole thing. I'm going to hook up play to here, and I'm going to use a line object. And so the way this works, all right, is if I say 0, 0, 1000, 1000, right? What this is going to do is this is going to tell the play object to play the first second of audio, normal speed. So it's saying start at 0, go to 1 second in over 1000 milliseconds. So it's where to go, how long to take to get there. It's target, time, target, time, target, time, da, 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 da. That's how you talk to line. You give it a list, right? This doesn't have to be, it's confusing here because the target value is also time. But imagine this, if I say 0, 0, 1000, 2000, it'll drop an octave. If I say 0, 0, 1500, it'll go up an octave, right? So this is saying start at 0, go to 1 second in over 500 milliseconds, right? If I set this to 100, it'll go 10 speed, right? If I say 1000, 0, 0, 1000, right, I'll play backwards. It'll start at 1 second in, rewind to 0, right? So that's how you play with the audio, right? So making a drum machine should be pretty easy. So this is my kick drum, right? And the cool thing about it is it's implicitly polyphonic. I can make 2 of these, right? They can both access fret and they can both play at the same time. So this should play from 1 second to 2 seconds. So it should be the snare drum. And if I want to hear both the bass and the snare drum at the same time, I just do this. Right? You can play them both simultaneously. Right? Same thing with the hi-hats. Let's get some hi-hats here. Right? So this would be 2000, 0, 3000, 1000. This would be closed hi-hat. Right? And then this would be an open hi-hat. And just to play lip service to performative realism, I'm going to make it so you can't play the open hi-hat and the closed hi-hat simultaneously. These will interrupt one another because they're on the same voice. They're sending messages to the same line object in play. So I can't play an open and a closed hi-hat at the same time. Right? They'll interrupt one another. Right? And then you can do, you know, crap like this, right? We can make like a metronome. Do, 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 do. And this will go off, you know, every 125 milliseconds. And then we can say, give me a random number between 0 and 2. And when you get a 0, right, play me a bass drum. Right? And let's pick a random number between 0 and 3. And when you get a 0, play me a snare drum. Right? And then like pick me a random number between 0 and 3, 0 and 2. When you get a 0, play a closed hi-hat. When you get a 1, play an open hi-hat. When you get a 2, do nothing. Right? And now I've made a random drum machine. Right? You got it? Pretty easy. Right? So that's pretty simple. So that's cool. So then we could do that with our body, right? We could play these with our body pretty easily, right? So we could say, let's make some MI theirs that just trigger bangs, right? So we're going to basically rejigger this MI there to not play a MIDI note, but just send out a bang, right? And we're going to save it as MI there bang. MI bang. What's it called? MI bang, whatever. Just something short that I can type. And so then all we got to do is all the kind of crap we were doing before, right? We're going to copy this from the motion detector, right? So we're going to do something like this. Do, 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 do. We're going to paste this someplace well out of the way. Sure. Right. And then we're just going to say, I just want 2 columns and 2 rows. Right? So we just get 4 numbers. MI bang. Right? And we're going to ditch this metronome. Let's save this. And we're call this motion drum machine. So this should give me a kick drum. This should give me a snare drum. This should give me a closed and open hi-hat. I think. Right, so let's turn this on, open it up. Right, so that's the bass drum. Closed hi-hat, open hi-hat, snare drum, or bass drum, snare drum. Right? Right? 4 quadrants of the screen, right? Make sense? Right? The rhythm of it is a little bit messy, right? It's a little bit bollock stuff. You know, because it doesn't actually sound like anything, right? So what you could do is you could rig it, right? We could cheat, put it on a beat, right? We could do some quantization. So one way we could do that is we could say, look, the bangs here do not actually trigger the note. What they do is they allow the next beat to trigger the note, right? So we could do something like this. We could bring back our metro going at 125 beats, or at 125 milliseconds, right? We could have these buttons. Let's get rid of these for a minute. We could have these buttons trigger a 1, right? Let's see if this works. We're going to send that into the right-hand side of an integer box. Okay, so this is, remember we were doing smoothing last time we used some of these? You send something into the right of an integer box, it doesn't come out until you bang it, right? So this is going to bang it. When it's a 1, it's going to fire this, and then it's also going to fill itself with a 0 for the next time. So the result of that, if I do this right, come on, get out of my way. Good enough. Right? Would be, it would trigger the bass drum and then send this into here to prevent it from being triggered again. Right? So if I duplicate this circuit, oh, I need that button too. If I duplicate this circuit, bass drum, snare drum, hi-hat, hi-hat. You're going to U, you're going to U, you're going to U. We hook all this up. 1, 2, 3. Turn it on. Now I'm in time. I'm only on a beat. Right? One way we could cheat this is get something happening in time, always in time. So I'm going to make like a little noise generates white noise. I'm going to multiply it by a little amplifier here. 0, 0, 1, 5, 0, 10. So this will trigger a little, right? So I'm going to use that as a beat. I'm going to make it not that loud though, 0.5. And we're going to hook this up. So you can so that proves you have a clock. We'll turn this way down. Right, so that's a way to kind of rig the user testing that. Right, so you can use it. So this is just and the same, and you can do the same thing to like just play a movie, right? We could have different quadrants switch films for an output, right? So if you move your hand up there, you see one movie. So it's pretty straightforward to do that. And it's kind of fun. So that's like a really simple thing. And all that's doing is looking at a bit of the image and figuring out the median pixel, right? The average pixel. It's not really looking at the image at all. It's just counting up white and black pixels and feeding it a number. It's barely doing anything. So that's one thing you can do. If you need something that's less triggery and more continuous, you have a bunch of options. One thing you can do is look at some simple things like finding the boundary of an image, a boundary of a color or something like that. You can also do something like, there's an entire package of objects for computer vision for Mac, so called CVJIT. And what they are is they're based on Intel's OpenCV library. OpenCV is Intel's open source computer vision library. There's versions of this library for processing, for open frameworks, for Macs, for all sorts of stuff, right? The Macs one is called cv.jit. And it's a bunch of objects that do stuff, right? There's an OS 10 version and a Windows version, right? And it's pretty straightforward, right? And I think I've got them installed. So this is where you need to go to download them. They're made by a guy named Jean-Marc Pelletier. CVJIT. So download them there. And so like a really classic example would be, let's grab all this and grab my camera again. So I'm going to do a slightly different kind of thing where what I'm going to do is something called a background subtraction. Whoa. Background subtraction. So what this is going to do is I'm going to do it whenever I hit the space bar. Alright, space bar. I'm going to send out the background. I'm going to send out a single frame and do the ABS diff from there. Right? And so if I do this and turn it all on, so here's how this works. I get the hell out of the way, hit the space, and let me make sure out of the way too. Hit the space bar, and now this is just showing the difference between me and the image I picked up when I hit the space bar. Okay? So this is like a silhouette of me subtracted from whatever was there before. If I walk out of the frame, it should go black again. Right? So I took a picture of the background and I'm subtracting myself from the background.
Right.
Okay.
Sorry, which is taking the picture of which command, which script is what?
This is a space bar.
Okay.
It's banging this. JIT matrix through 0. So this is taking the image. The
Okay.
through 0 means it needs a bang to send out. So this will take a photo. This will take a photo of the room. So like one way I could fuck it up is I could put my arm in there and like take a photo of my arm. And now it's subtracting me from whatever is in there. You know.
Okay.
Right.
That's great.
Yeah, but this will, you know, get rid of it. You got to be careful with this camera because the built-in camera on the Mac kind of sucks. It has an auto exposure function that you can't shut off, right? So that's why that didn't work, and now I've got this gray crap behind me. So you would want to use a real camera, but this is sort of working. And so one thing you could do with this is run it through like a CVJIT algorithm. And so like a really easy one is this thing called CVJIT centroids. This will compute the center of mass of an image. That is amazing. That sounds great. All right. So what this thing is telling me, all right, is this thing is telling me, right now it's putting out -1s, which means there's nothing in there. But what this is telling me is this is telling me the center of mass of the image. This is telling me the pixel at which the energy is. It's basically the mean in 2 dimensions, right? It's a split point of energy in 2 dimensions. The third number is telling you how many pixels are on in the image, how many white pixels are in the image. Right? So if I were to plot this, if I were to map this, I could get me like a little 2D slider. That's not a 2D slider. What is it called? Picked slider. Yeah, that's a little shitty 2D slider. I'm gonna get info on it and say value at bottom is 239, value at top is 0, value at left is 0, 319. So I'm gonna rig this up. And I think I can make the background transparent. We're gonna stick it on top of this. Right? And I think this will work. Did I size this right? Okay, so I get out of the way, hit the button. So you see that little circle? That's the middle of me. Right? Right? So that's what it thinks is the center of this, the center of the image. Right? So that number that's right in the middle of my chest we could use for something. Right? You see what I'm saying? Right? So we can control something with it.
Can you show that?
Yeah, sure. So, so this is what's going on. It's doing background subtraction. So let's color it, right? So this is this whole bit is computing background subtraction. So this is just you hitting the space bar to get rid of, you know, whatever is going on, right? Same thing with you. You can get red too, right? And then this is computing it's subtracting from the image, it's thresholding it, and then sending it to this thing CVJIT centroids, and then I'm drawing, there's a little thing called pick slider. This is just for show, but there's a little overlay, right, with a little knob on it, right? And so this is just to make me feel better that it's working. I'm sticking it on top of here. What I really want to do is use this for something, right? Use these numbers. And so I can say, look, I'm giving you numbers between 0 and 319, make them 0 to 127. I'm going to get rid of negative ones because I don't care about them. That means nothing's there. And I could do something like, you know, we can make some bad MIDI. Alright, so if I get out of the way. Shut up! Shush. Low notes, high notes, high notes, low notes, high notes. All right, easy enough. Yeah. Right. Shut up. Makes sense. So like we're just getting a continuous value from looking at the point. So that's a way to get a silhouette. It's an easy way to get a silhouette without going through the work of making sure the background is a blank color, right? I wouldn't need to use background subtraction if I could guarantee that the background is something I could get rid of, right? That would be one advantage of using like a green screen, right? Is I could chroma key it out, right? And then get a black and white mask and just plug it in, right? Or a white wall. You could point your camera at a white wall. Yeah.
Let's work with more than one person that use one screen.
You have to do a little bit of work for that. You know, yeah. So this will get confused. This is just telling you the average of the image, of the whole image. And it's giving you one set of numbers. If you want to track blobs, if you want to track regions, whatever, independently. So like say, let's see if we can figure out an example of this. Let's more than one red marker. This will be fun. This might not work. The Pantone swatches from the thesis show are red. Some of them are red, sort of. I don't feel like. Oh, this is red. This might work. Okay. These are almost the same red, right? So here's what we could do. Let me save this for a sec. Centroids 1. Right. So let's imagine the following. Let's make another one. Call it Centroids 2. Or let's call it keying. Mask key. So here's what we're going to do. Now we're going to say, fuck this background subtraction stuff. I don't care. Now we're actually going to really look at color for a minute. So we're going to hook this up. That didn't work. Let's get rid of this. We're going to hook this up to here and get our color image back. Oh, shut up. Stop being mad at me. Right. These are kind of sort of the same color. Right? So I'm going to figure out how to key them. Right? So I'm going to use that object I showed you a little while ago, that thing called sucka. Right? Stick it on here and make it so I can find the red. Right, so this is red. Beep. Yep, that's sort of red. We're going to make sure this works first. And we're going to use this color $4, $1, $2, $3. So we're going to need a chroma key, JIT chroma key. So you go into the JIT chroma key object. You're my color that I want to get rid of. I want a tolerance of 0.2 and a fade of 0.1. I'm just making this up. I don't actually know if this is right. And I'm going to put it in mode, I think mode 1 is the one. This should give me a black and white image. Let's try this. Nah. Okay, that's backwards. Let's try mode 2. Nah. Nope, that doesn't do what I thought it did. Okay, let's go with mode 1 and we'll fix it. Nah. Yeah. So you see that? It's left the pen black, right? The tolerance is too high. It's got like my face in there a little bit. So let's turn the tolerance back. Yep. There's the pen, and there's this whatever it is, right? So we've got these kind of keyed out, black and white, right? We're going to flip them around to make it sort of fairly easy. First of all, we're going to make a black and white RGB to Luma, because they are black and white, but they're not really black and white, so we're going to do that first. And then we're going to put a threshold on them, and we're going to say JIT less than, I don't know, 0.5, I guess, something like that. Let's see if this works. So now if I hold up the thing, yeah, there they are. There's our little, right? So here's all the red stuff. You see that? We've got all the red stuff in a mask, right? So your hat should work, actually. It should kind of come in, right? Anything that's bright red should make it through, right? And so now it's about like tracking these independently, right? Doing a bit of work, and so there's a whole, set of now it becomes like a bit more complicated, right? So I got to do some noise reduction. I might want to do some linking. You got to do some whole stuff to like train the computer into the idea that these things are related. And actually, maybe just make it less than 1. Nope, that's too easy. All right. How about less than 0.9? That's a little better, right? And so we can label. So there's an object called CVJIT label. CVJIT label. And what this will do, I'm going to put in something called char mode, I think it's called. Let's see. Attributes. Hey, char mode. And what this will do, and there's a threshold as well. I'm going to set it to threshold 100. So what this is going to do is this is going to go through the image, all right, starting in the upper left-hand corner, It's going to go like, first time it only works with binary images, black and white images. So it's going to go, first time it hits a white pixel, it's going to say, you're blob number 1. Next time it hits a white pixel, it'll see if it's connected to blob number 1 and keep calling it blob number 2. If it finds white pixels that aren't connected in any way to blob number 1, they'll call those blob number 2. And so on and so forth. And so what it'll do is it'll track up to 255 individual self-contained images and label them, give them a number in an output matrix. So what it's going to do is it's going to generate an image that looks like very, very dark grayscale, but the actual pixel values are which blob. So I can use a JIT equals to find that. So I'm going to look for all the ones, right? And so this will be blob number 1, whatever blob number 1 is. And this will be blob number 2, whatever blob number 2 is. So that's blob number 1. You see that? That's blob number 2. See what happened? Distinguish them, right? So now I can centroids those two things individually, right? That'd be easy enough to do. It's hard because as soon as they cross, they'll get renumbered, right? It starts numbering in the upper left. So if I move this guy up, it'll flip, right? See what just happens? Depending on the orientation of these, it'll get confused. So you have to do some work with that as well to keep it stable. But it'll do it, right? There's an object called CVJIT blob centroids, which will individually give you all the centroids of all the blobs as a matrix. So like one thing we could do pretty quickly is, and we can print them out, so this will tell me where they are. So if I print them out, these are all the X, Y positions of all the blobs and how large they are, right? So I could draw them, right? I guess draw them. So let's try that. Let's make a little, let's OpenGLify this thing. Key Metro. That's a good start. GL render Bob. And we're going to make it flat. And we're going to make the background black. Right. Usual stuff. Get everybody out of my way. We're going to say trigger, bang, bang, erase. Okay, so this is going to send out the camera in between erasing and drawing the renderer. The renderer is going to go into a JIT window called Bob. He's living there, it's all fine. I'm going to do my usual thing where I have the key command, make it go full screen. And yay. And I'm going to turn off something called the depth buffer. I'm going to make this thing like 2-dimensional. And so what we're going to do is we're going to draw my image onto a video plane, Bob, and call it layer 1. That's not how you do that. GL video plane, and I want it to. I'm going to make it like 1.3 to 1, and this should work, right? So this will draw. Oops. Help if I turn this back on. This will draw just the red bits onto a video plane. So this is showing me what I'm doing. And then what we're going to do is we're going to take all these guys and we're going to say, okay, unjoin to. You're giving me an X and a Y. You're also giving me, I bet you're giving me a size as well. Yeah, you're giving me a size as well. So I'm going to get me a JIT-GL grid shape. I'm going to make it go render to Bob. I'm going to make it a donut. I'm going to turn on lighting and all that crap. Lighting, 1, smooth, whatever, 1. And yeah, that's good enough. And what else do I want to do? Oh, I want to turn off the automatic. Automatic 0. actually, I'm going to turn off automatic here too. Automatic 0, because I need to bang that at the end. Actually, I need to bang that first, right? So I'm going to draw the video plane, LL. I'm going to draw the video plane before I draw anything else on top of it. So it's going to draw this, and then it's going to go up here and do all its shit. And then what I need to know is, I'm going to scale all these numbers. So this is the x position, 0 to 319. It's going to be negative 1.333 to 1.333 to 3, whatever. This is the y. It's 0 to 239. I think negative is the bottom, so I think I want it to go from 1 to negative 1. And then this is the scale, and I have absolutely no idea what kind of numbers these are. Okay, they're like 100 and something. I'm going to divide it by 500. I'm just making this up. This is going to be the scale of the donut. This is going to be joined up again, and this is going to be the position of the donut. $1, $2, and this is going to draw it. Let's see if this works. Okay, that's too big. I'm going to say that donut is really big. Let's try 2,000. That's slightly better. Why do I not? Oh. I need you to draw after you get there. Right, so there's a video plan. There we go. So that's it under my dot. Here's the other ones. So these are the blobs it's finding. These are the silhouettes it's finding. Right? Being drawn.
What does jitter do?
I'll show you. Jit iter is kind of cool. What it does is so the trick is, here's what's going on. All this stuff is still in matrix land. So JitGL label puts out an image, okay? Puts out a black and white image where the pixel values are no longer like black to white or anything like that. What they are is they're the numeric value of the blob that pixel is in, right? So 0 will mean it's not part of any blob, 1 will mean it's part of the first area, 2 will mean it's part of the second area. Centroids will take that data, analyze all the blobs, and put out a matrix of x, y size numbers. It's putting out a 3-plane floating point matrix. This thing sticks it out into max land. It takes a matrix and dumps out every value in those matrices as a list. Since we'll dump it out all concurrently. We could do this without this. We could use something called JitGL multiple, but I don't really feel like it. So this is just dumping it out. So if you send in
The iter, the jit.iter, that's the one that makes a list out of the blobs?
yeah, so let me show you. Jit iter. So like, let's say I have a jit noise. Check this out. So this is something that's just going to generate noise, right? Like random values, like just random colors. If I jit iter that, okay, it'll print them all out for me, right? Poof. These are all the values that are in there, okay, as max messages. And if you need to know which ones they are, the middle outlet will actually tell you. So values, coordinates, right? So if I do this one more time, this is telling you all the stuff you need to know. So at coordinate 0, 0, I've got 22, 67, 184, 213. At coordinates 1, 0, I've got 161, blah, 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 right? So what I'm doing is I'm taking this matrix and blasting it out as a succession of messages, scaling them all, right, appropriately, and then scaling the donut, positioning the donut, drawing the donut, scaling the donut, positioning the donut, drawing the donut. So there's only one blob, it'll only draw one donut. If there's 15 blobs, it will draw 15 donuts, right? So if I change the threshold, this is the minimum size in pixels for a blob. If I change this to 10, I'm going to get a lot more blobs and a lot more donuts. You see all those little donuts now? Right? So those are small blobs. Right? If I set the threshold to 0 or 1, I'm going to get a shit ton of blobs. See all those little guys in there? It's drawing all these little donuts. Right?
So when you say unjoined tree, what is it unjoined?
Splitting up the list. So what it's doing is it's taking, this is 3 numbers coming out at once, right? Right? So this is splitting them up so that this number goes here, this number goes there, this number goes there, right? So this is the size, this is the y, this is the x. It goes x, y size. And then it can process them independently. So it can scale them, join them up again. So another way to do this would be to join all 3 of them up and do this in one compound message. That would have been okay too. I could have said scale, position $1, $2, scale $3. Bang. That's fine also. It's the same thing. Right? This will do the exact same thing. Let me make the donut, let me make the video plane red. Color 1001. So you can tell the difference. And let me make the donuts white. Right? Yeah. So see that? That's the blobs. That's the blob it found. Here's a couple more. Right? And so you could use that to make sound, right? Assuming you can stabilize the image. Right? So there's a whole bunch of things you can do with image morphology to try to help you build silhouettes out of these. Right? So for example, I could take this guy, this kind of crappy pen thing, and play with the threshold and try to blur it all together. Right? I could use an object like, let's see, let's try CV, JIT, dilate. I can't remember what the difference is between any of these. Yeah, so this will turn a pixel on if any of its neighbors are on. So this is really useful for filling in holes. Let's put this down here so we can watch, see what it does. All right, so let's try this. This will do a bet. This will help us see what it did. It filled in a bunch of the gaps, and I've only got 2 blobs instead of little ones. You could do this over and over and over again until you get like a solid shape, if you want. Right? So for example, if I wanted to key out my face, that's fun. You know, into better connected regions, you know, based on my skin tone. Ooh, that's fun. The background is basically my skin tone, so it's not helpful. Let's try the blue in my glasses. There we go. Oh, except that screws up as soon as I go full screen. That's annoying. Or the red in my beard. You know, you can sort of figure out, you can find a color that works. Maybe we need the tolerance to be smaller. Yeah, that's just my face. See that? I've done a reasonably good job there of keying out my face. So dilate will help connect regions. The opposite of CV-JIT erode. Erode will get rid of stray pixels. So one thing you can do a lot is you can get rid of the stray pixels and then dilate the remaining pixels. And this will help you get a more like consistent mask. Right? Right, so you can do like sort of shape recognition that way. That makes sense? You can do some stuff like that. And play around with them. Erode will just get rid of any pixel that's on that doesn't have any neighbors that are on. So it'll kill stray pixels. Dilate will turn anything on that has any neighbor that's on. So it can be used to fill in gaps, small gaps. Right?
So it's different from the color tracking?
We're doing color tracking basically. We're using the chroma key to do our color tracking. Right. Any color tracking algorithm makes a black and white mask underneath the hood based on the color.
Really?
Sure, how else would it do it? Right?
But then you always have to make it black and white to play with it.
Yeah, you make it black and white to play with it, but we could run multiple colors in tandem.
As well.
Yeah, yeah, so we could have like a green channel, a red channel, and a blue channel and look at independent colors. Yeah, it's everything always ends up being a binary image, right? No matter what, right? The computer doesn't give a shit about the color red. It just gives a shit about true or false,
Oh,
right? It's a
I
test,
see.
right? What we're doing is a test here, right? We're using chroma key to generate a test of whether something is within the range of red or not, right? And so if it's red, it ends up as a true pixel, which shows up white. And if it's not, it shows up as a false pixel, which shows up black, a 1 or a 0. Yeah. And then you can do math based on that, which is always fun. Yeah, so this will fill in the thing.
Right, right.
This is sort of ridiculous, whatever I'm doing here. But it kind of works, right? So we could use all these guys to make some kind of horrible sound thing. Right? Do I still have? Yes, I do. Amazing. This will be fun. So we could drag all these guys in. Right, awful. But it's doing chords because it's doing multiple blobs. Right? If I get out of the way, or if I key it just to the pen again, let's key it back to the pen. Right. Right, I'm doing a pretty good job of tracking that. I could probably strip out the zeros. A 0 means there's nothing there. That's what that low bass note is. Right. Now the chorus. Right, so that's color tracking, right? That's what we're doing, basically. This is basic color tracking, right? It's a simple way to do color tracking. There's an object in Max that will do sort of simple color tracking on its own. It's called JIT findbounds. It'll give you the upper left and lower right of the areas in the screen that have a certain color range in them. It's a little frustrating. I prefer this because it'll actually give you the center of a blob, not its boundaries. But it depends what you need to do, right? Some other things that are kind of fun to play with this are something like there's a feature recognition object. There's a thing called CVJIT features. We can look at some of this next time. Features, right, that will look for areas of high contrast and tag them, right, and put them out as numbers. There's a thing, there are optical flow objects, which will tell you if images from frame to frame are moving to the left or moving to the right, stuff like that. So that's kind of easy. Anyways, does that make sense? So you can sort of like play around with it. There's a very good overview file that is not here, so let me find it. It's part of the CVJIT package, CVJIT. Yeah, that has all the objects, right? So you can like get at all the help files from it. This is an old one. This is a really old one. 7.72 object guide. This is the new one. So these are all the objects that come with it. So there's things like, let's close this. There's things like HS flow. This is an optical flow analyzer. So this will take an image and detect which pixels are moving in which direction. You see that? So like, different colors represent different kind of spatial things. That you can use to detect motion. There's another one called LK flow that uses a slightly different methodology for the same thing, right? So you can use that to detect stuff. There is a very useful thing called CVJIT moments that maybe I'll show you guys later that lets you detect shape descriptors. These are things called moments of inertia. This is actually how things like Golan-Levin stuff works, like the blobs and whatever. So what it'll do is it delivers 14 numbers, 7 of which are called the moments of inertia, 7 of which are called the hue invariance. But they're numbers about, like, given a blob, is it taller than it is wide? Is it more concave or more convex? Is it jaggy or smooth, right? It's like all these metrics on an image that you can use to find things, right? And you can use moments of inertia eventually to do things like face detection and stuff like that. It has a simple face detector. So this is like this will find my face. Hello.
Does it work better with the Kinect?
Sort of. Yeah, this won't actually work with the Kinect depth image because it's got the wrong model. This is looking for, this thing actually needs color, or black and white. It needs grayscale. It can't do depth. You know, because what this is doing is this is loading something called a HAR model, an HAAR model, right, which is a sort of standard computer vision thing, right? You know that Britney Spears thing I did? You know what I'm talking about? That thing is a big. Did I show you guys this ridiculous thing?
So that was you take one frame of like one part of the frame.
Yeah.
And
Yeah, this is like a subdivide thing, right? So this is a thing I made, right? So this is like a computational model of information, okay? So what you do is you download 3,000 paparazzi photos of Britney Spears. You can train the computer to know what she looks like. And then you can feed any footage of her in, and it will find her and lock her eyes. Right? So it's basically locating a blonde woman wearing a lot of mascara, right? And it will center her eyes, right? And this is something called a HAR model. It's HAAR. It's a Von HAR, and it's a computer vision model. And it's a big honking XML file that, given a blob, it will given a shape, an analyzed shape, it will sort of drill down and find things in that shape, right? So like your head is one of those platonic forms. Your head is 5 by 7, and that unit is the width of your eye, right? So your head is usually 5 eye widths wide and 7 eye widths tall. And your eyes are at the golden mean of your face, right? They're like whatever that is, 67 point or whatever, 70 whatever percent of your face, right? So you can find those things, and you can locate eyes. Right? And it does this, right? So her videos are panning around, her eyes are locked. It's easy enough. So that's kind of fun. And so that is basically somewhere in here, somewhere in this stupid thing, is some, big nasty data set of crap, right? But this is like all her X and Y's for all her eyes and all her videos. Yeah, so it's not so bad. Yeah, so you can do a lot of that stuff. Anyway, let's take a break and then we'll play with the Kinect.